Okay, well, hi everyone. Thanks for sticking around. It's getting late, so I'll try to be brief, although I would like to have my session in a bit of a interactive manner. Hopefully we can solve some challenges or think about them. As the previous presenter said, I really like the Albert Einstein quote. It almost landed in my presentation, which fortunately didn't. We thought about the problem for a good 45 minutes. So let's spend another 10 minutes and then let's maybe brainstorm some solutions. So I'm going to start briefly about, my name is Filip. I work currently for Xivia Security. I'm a cloud security shepherd, which means I basically do a very similar job to a normal shepherd, which takes care of the flock. In my case, it's usually the cloud for other customers, from writing code to creating roadmaps for the organization for their cloud migrations or cloud plans. So if you want to get in touch, feel free by all means to screenshot photo. This will appear at the end of the presentation as well. So quick agenda. So cloud native, what is it? So we have a context. We're on the same page. What terms we're going to use, and then I run through the brand new. I do believe that's the newest OWASP initiative, the Cloud Native Application Security Top 10. So I'm going to touch briefly on that, and hopefully we'll be able to turn it into a almost brainstorming session later down the line. So quick disclaimer. I will mention different tools, make sure they're applicable for your use cases. So there will be some kind of ready-made solutions. I do not recommend or endorse any of those tools, so make sure you do your research. Of course, the lists are not exhaustive, so there's way more things than there's time for in one presentation. So, cloud native. So this is our beloved, if you're familiar with the CNCF landscape, we get all these cool toys, we get the ability to deploy stuff, so many services, it's honestly beginning to get ridiculous. They're really categorizing it and categories on subcategories on subcategories. So it's very hard to actually keep it all in check. However, with that freedom, with that ability for us to deploy, to work, with that power comes responsibility as well. So, and when we are talking about cloud application security or cloud native application security, we're not only talking about the web application. We're really talking about the components the application is running on, because the goal is to give us as engineers the ability to really manage our full stack. So we really want to be able to do the velocity. So we don't want to wait for people to deploy services for us. We don't want to wait for security to do the checks. We don't want to basically lose time, because the business hates losing time. Time is money right now. And we really need to keep moving forward. So, as the previous presenters mentioned, this is probably a very familiar picture for everyone. This is how most of us started. So we have our beautiful monolith with some entry points, a gigantic database, and we're trying to slowly move to this, basically. So just for the clarity, I will use this as a reference point for what cloud native means for the purposes of this presentation. So we're going to be looking at container services. We're going to be talking about a event-driven basically architecture, where the services actually do not talk directly necessarily to each other, but they talk via an event bus, front-end API gateway, different front-ends. Main focus on the orchestration layer is Kubernetes. It is the de facto standard by now for orchestration within the cloud and also outside cloud if you're running it on your on-premise. Okay, so these microservices can use different languages. You might want to use Go here, Rust here for whatever reason. So we're really talking about totally different things talking to each other, and they need to understand each other. And the data passed between these services is also something we need to keep in mind, because just because something comes in here, lands in the event bus, and then let's say the catalog service picks it up or the identity service picks it up, how does the data flow actually back and forth between all these services? And zooming again out, actually, so cloud native is way more than just that Kubernetes, the orchestration layer, containers. It's actually the pipeline also comes into effect. Okay, how do you deploy it? What do you do with all these things? And the whole DevOps thought process behind it as well, the way you operate it, the way you actually develop the application, the way you package it, how do you operate it afterwards, how do you look after the application in general. Microservices, that's basically the previous picture for Kubernetes, and effectively containers, so the way we package, we deploy, we handle all the application code. So this is kind of why the OWASP CNAS Top 10 came out. So there's a link if you want to go ahead. So this is a very brand new project. It is less than 18 months old. I believe April 2021 is the official stamp on the page. Okay, this is when we started. The goal is to cover the application and actually the platform as well. So that's very important. It's trying to fill the gap between the cloud security and the OWASP Top 10 issues. It kind of tries to bundle it into one framework where a single team that's trying to build cloud-native applications can work with. So very brand new project. Top 10, so there's 10 controls. It is effectively a list of lists right now, which means, there's a general overarching idea for each control, and underneath that there's multiple possible challenges, let's put it like that. So, if you do, after this talk, if you do want to have a chat about it, or if you do want to contribute to the project, by all means, because we need it. We would definitely need different opinions, and we definitely need to have a discussion, and we have to have arguments as well, because in the end, this is something we're doing for us, for the community. So by all means, go ahead and contribute. So I'd like to go through the top 10 and probe for ideas. Okay, we're going to go for per each challenge, and then maybe do a quick brainstorm session. Okay, what's happening? What could we possibly do here? And hopefully come out maybe with an actionable item. So, starting number 1, insecure cloud container or orchestration configuration. So, now my question is, yes, no, have you seen it? Any ideas? Do you do anything with it? Anyone? Any takers? Yeah?
Insecure cloud configurations is one of the reasons why we actually sell our CSP tool. I think there's been a couple of research papers that actually said that the only reason people in the cloud got hacked was because of misconfiguration.
Well, this is not without the reason. This is number 1. You know, a lot of OWASP top 10s, there is some sort of logic to those, and not without the reason. This is number 1. So that's one thing. Any other takers on ideas on how could we possibly tackle it?
Containers should be immutable.
Yeah, that's something as well. That's a good idea. So you at least prevent misconfigurations that might happen on the fly.
I think the previous talk ties in quite nice with this because they mentioned OPA a little bit.
Yeah.
And I think OPA is really good to combine with this to prevent misconfiguration because you can create policies and compare the environment against those policies.
Yeah. Okay. Oh, great. Oops, we went too far. Okay, so my choice actually is just simply baselines. The overall cloud is not really a new thing. If you look at the velocity, everything is developing. Kubernetes is also, relatively speaking, not new anymore. It's a pretty mature product. So there are baselines. Cloud vendors provide us with baselines. Azure, AWS, Google, they have best practices. For Docker containers, there's also sane baselines. Okay, don't do these things. So there's actually for these baselines, it's also important not to try to reinvent the wheel, because these baselines have been here for a while, and you might want to, pimp out that wheel somehow or adjust to your needs. But overall, that's been agreed upon by the industry, and unless you have a really weird edge case, it's generally a good idea to stick to those because they've been tried and tested. And to help us maybe with checking those baselines are a few tools. So this one, TV from Aqua, is for Docker containers. It will basically look at the Docker file and tell you, okay, you're doing things good. If you're doing these things, you should have a look. So, root user, really basic industry standard same values, which in most cases you can almost immediately implement in your pipelines as basically as an engineer, and you will simply get a report. So this doesn't really break builds. You can stop builds if you configure it, but by default, most of the tools I present, you can just shove it into the pipeline and you will simply get a report. That's it. So and then you can take actions and tweak and adjust as necessary. So Checkoff is a tool to check infrastructure as code, CloudFormation, I believe, Azure RM now, and Terraform. So also it uses the baselines from the vendors. The Center for Internet Security baselines are implemented here as rules, and it will also give you, your bucket is public kind of deal. Your VM has a public IP. Does it make sense? So you can really go ahead and just, again, shove it in there, get a report, and do something with that information later down the line. Kubelinter, similar for Kubernetes, for deployments. It basically does a few checks on the deployment template on the YAML file to make sure, this is sane, you are good to go. Right. Moving forward, our favorite, OWASP top, I never remember. This is still the number one?
Yeah.
Injection? In top 10? Yeah. So this is number 2 here. I'm not gonna really get in depth. Sorry for that. It's my... Don't look. I need to fix it. Sorry for that. Let me turn this off until tomorrow. I think there have been whole conferences about this topic. So I'm just kind of gonna refer you to this input validation. Never trust what the users put in, basically into your application. The easiest way, create developer awareness, because this is a lot of the time something developers need to handle. You could possibly use web application firewalls, but then you really have to have the context of what kind of injection you might expect. It is a control, it is possible, but it does require extra work and it might require continuous tuning. Some of the CSPs offer web application firewalls that kind of learn and adapt, and might basically look at variation and behavioral changes in the web application, in the inputs that the application gets. So it is one control you could look at as well. So input validation cheat sheet. So if anything, go sit down with your developers, and if you do awareness sessions or your developer self, share it with the juniors, share it with your colleagues. Basically, this is probably the best approach to start solving this problem. Yeah, go ahead.
I have one question regarding the tools you mentioned. If you go to slide that, you were mentioning about few tools which can be used to monitor, like this one. Is this only the Kubernetes cluster, or what happens inside a container? So say suppose if I am creating a database.
I will get to that. I will get to what happens inside. That's one of the controls. So I will get. This is basically mainly for. I call this stage pre-deployment. So before it actually lands on you can make these tools to break the build basically before it gets to the container registry, or before the infra gets deployed, or before the deployment even touches your Kubernetes cluster. So, input validation, and this is also a favorite of the OWASP top 10. So, and we're talking really about authentication and authorization from the, infrastructure itself, how services talk to each other, how on the network level, how things communicate to the application code itself. So how your users access the database. Do you have proper separation? So, let's say, unauthenticated API access on a microservice, or over-permissive cloud IAM roles, lack of orchestrator trust nodes. So any takers, any ideas on how could we possibly, prevent this, maybe detect this? Any takers? Of course, proper one. That's basically, that's a very excellent valid point.
Short-living virtual authentication. Single use.
That's. I went for simply least privilege. We have our dev environments, we have our staging environments, we have our production environments. Now, I don't need to hear answers out loud. Answer yourself honestly. How do privileges look across those three environments? Basically, right? How you get from, how does it from dev to stage to production? Does there anything changes? Does anyone actually do anything with the privileges that are being generated? Development speed is very important, but at a certain point, a quality gate has to be put in to check, okay, do we need that much permission? Do we need that much access, actually? It is a pretty, I don't want to say difficult problem. There's not a lot of tooling around this, so there's definitely opportunities to write something if you're creative enough to. And one idea is to, for instance, if you have an application in dev, you just give it generic permissions, done. But then based on the actual API calls, you reverse engineer the proper permissions, which then you can translate, for instance, into a custom role, which then you apply into production. Because, in dev, you at least narrow it down, rather. Because, do you need really even sometimes read permissions on a bucket, let's say? Maybe you just need write. You just care about writing files to the bucket. You don't care about listing them. You don't care about reading them. Might be a case, for instance. So, and with read and write, the attackers can get a huge amount of information. They can let access your whole bucket because of that and all the files that are there.
How about providing just-in-time access?
That's also just-in-time access, but still, the least privilege needs to be applicable, because if you still provide extended access, it doesn't matter if the attacker has it for 5 minutes or for an hour, or if he has a token that lasts a year. So, this at least will enable you to limit the blast radius if something happens, because something will happen. Let's be fair. These are kind of inevitable facts of life. Things will go wrong. So at least the least you can do is to be prepared. Right. So CI/CD, CD pipeline, and software supply chains. Very in the last few years, very, I think, near and dear to a lot of us, and especially if you were, engaged with SolarWinds, maybe CodeCoff, NotPetya. That's basically the most expensive ransomware attack that started by a supply chain. Basically, an update was pushed to a tax software, and that basically propagated all across the world. So, and we're talking billions of dollars lost, and they're still kind of recovering from it until today. So, so some of the things for this would be insufficient authentication on the pipeline, use of untrusted images, so basically or over-permissive registry access to the container registries themselves. So, any takers, ideas?
Hard-coded credentials in libraries.
Yeah. So this is basically, But how?
Composition analysis, materials.
Yeah. That's. Yeah.
Dependency checking.
Yeah.
And image scanning.
Yeah.
But also monitoring of the artifactory, like JFrog, X-Ray, which takes timestamp and check if after 2 months there is a vulnerability and where it was deployed.
So all valid points, absolutely. As I said, this is really a list of lists. So there's multiple underlying issues. I decided to tackle this one. Base image control. Yeah. So trust but verify. So it's very nice that, the official, Ubuntu images, that Google has its COS images, whatever provider right now, every single large cloud provider comes with a container registry. Unless you need hundreds of thousands base images, there's no reason not to have something that grabs those images from the outside, puts it in your controlled container registry, where you actually can look at them and control and make sure that there is, for instance, a delay in pulling images from outside. So
the thing is that we have no control over some libraries, especially open source.
Yeah.
Even we have either possibility to froze to the given version, but then we will not have the latest update, or trust that the authors will be trusted.
It's all about risk, right? It is all about, also boils down how much risk, maybe not us as engineers are willing to take, but how much risk is the business willing to take, right? Because in the end, we can only tell them, okay, this is the problems we see. These might be the risk that might materialize out of those problems, and are you okay with it? If you're not okay, well, then we need to do something to reduce the risk to a level the business is comfortable with. So whatever it might be, this, as I said, this is just one control, one action. That's for one tiny piece for this whole issue. This is a massive. There's whole conferences around it, whole issues. A few of my colleagues from Xibia speak on this. Basically, there's basically, this is massive. This is massive, and we need to kind of figure it out. That's why we need to figure it out as a group, effectively.
Well, what about what you build on top of the base image?
Yeah, well, that's where we're gonna get to it. That's also go ahead.
Especially about front-end libraries.
Yeah.
Do you have any smart ideas about that? Because things like Google Maps, you don't even want to start looking at it.
Yeah. So it's as I said, this does in the end boil down to the risk. There are tools that can check those libraries. You can monitor them. Failure is that's kind of the first thing I have in my LinkedIn profile. Even failure is inevitable. Shit is going to hit the fan at a certain point. You can really, put a funnel behind that fan to make sure it just goes one way or the other. It has to go somewhere. And it's best if you're in control, and it's best if you can direct where the blast goes. And because then you're able to control.
But that may be crazy idea. Sorry. We are focusing on our side, our organization, how to prevent those problems. But maybe there should be initiative how to, normalize, help open source organic teams.
By all means, contribute. By all, that's the whole thing. If I can, inspire one of you to, add something to this framework, I'm happy. That my goal has been achieved, basically. So that's really so. Maybe let's move on for the sake of time. So insecure secret storage. So we're really talking, orchestrator secrets stored unencrypted in config maps or even in secrets. Still not good enough. API keys, passwords, that's the usual hard-coded application secret. We do still, see it around. I might go maybe a bit quicker for this one, jump. So KMS encryption. For a lot of us, we're transitioning from that monolith to that cloud native, and it's just, for one reason or another, it might not be possible to immediately just remove those secrets, because it might, the application has to be re-engineered, re-architected. So if you do need to store those secrets, at least keep them stored encrypted. Every single cloud provider has a KMS server. They provide functionality where it's almost a checkbox, where you can, and then the master control plane for the Kubernetes cluster actually takes care of pulling the secrets, sending them out, injecting them into memory, and that's where they stored really. So they don't really even have to be stored within the environment variables. So you really have to do a memory dump from the container itself to be able to access these secrets. So I have one project I want to plug in, OWASP Secrets, by two ex-colleagues of mine, Jeroen and Ben de Haan. Jeroen Willemsen. Go ahead, look at it. This will give you an idea of what can go wrong, and show it to your to the other engineers, SREs, developers. This will help you understand what can possibly go wrong. What are the most common issues and most common problems with secrets within a Kubernetes cluster? So definitely worth spending some time and looking at. Right. 6 is over-permissive or insecure network policies. I don't know. Maybe quick question: how many of you actually implement network policies on your Kubernetes cluster? Yeah, there we go.
Was right? The only one?
No, it was another one. Another person. So this is really, all of the services are loosely coupled. So, they often rely on ancillary services that they need to communicate to. And it is really critical to apply the proper and relatively strict network permissions to ensure if an attacker lands somewhere within your application, they cannot just walk freely around without any repercussions, really. So, and this can be over-permissive pod-to-pod communication. This can be internal microservices exposed to public, and network traffic to unknown or malicious domains not blocked. So again, a very, very broad issue, relatively similar to what you could possibly encounter with an IIS or even on-prem, right? Your application it's basically network. So the model in Kubernetes might change, how the network might look changes, but the challenge is effectively the same. I don't know, any ideas?
Service mesh.
Yeah, service mesh. Yeah, that's one thing. So I went simply for egress control. I think that's a good point to start. Does your application actually need to initiate connections to the outside? Right? Does it actually need that functionality? There might be in some cases, yes, but I don't think all of your microservices need to do that, right? They don't need to reach out to Google. They don't need to reach out to wherever they are. So there's
the problem of ingress control is worse than egress control.
Well, that's the thing. If controlling the egress severely reduces the blast radius because it severely reduces the capability to exfiltrate and reach out to the outside. So we're tackling really one problem out of many. Yes?
Yeah. Totally different problem. We actually have a product called Container Security, where we monitor all containers, and if we see an interactive shell being started, we simply kill the container.
Yeah, there will be a slide for you then as well. Not maybe directly with the name, but it will be a relevant slide. So, Calico Cilium to basically network level services that you can really, without too much hassle, inject to a Kubernetes cluster, and they will help you to control and basically the traffic on the network level. So, be it pod-to-pod, namespace to namespace, tag-based, definitely worth looking at.
It looks cool as well.
Yeah. So it looks cool as well.
Yeah,
they have GUIs, and you can, if you ever wanted a movie like dashboard to impress, anybody from higher up.
Yeah.
These two. And there's multiple more that look even fancier. So definitely very, very flashy. Right. Using components with known vulnerabilities. Yeah. Legacy applications, things are being done the way they have been done. We have a huge amount of dependencies, open source software, which oftentimes contain known vulnerabilities. So, be it source packages, platform versions of platforms, frameworks for components, or just simply, other known vulnerable components. Any takers on this one?
Software bill of material, SCA. So to see what's loaded, and RASP, so you can defend against it.
Yeah. So Mike was SCA, effectively. Know what you have, because then at least you can do something about it. Right? So, OWASP dependency checker, plug, OWASP dependency checker, SNCC, open SCA. Go ahead.
Yeah, in combination with the previous control, we see that cloud service providers sometimes mandate access to repositories, which is tricky given the fact that it's relatively easy to upload contained software to the repository, and then you have to open that repository, otherwise the cloud service provider will not give you support. What do you think about that?
Well, that's where that's where kind of I can refer to the few slides back with the baseline image control, because you can use package control as well. You can host your own repositories in that case, for instance, right? If you know what you have, you can make sure you have it. There is a certain degree of freedom we want to give to our developers. But in the end, when it comes to production, you might want to have this software composition analysis and a software bill of materials. And then, I need to have these packages, and the ideal situation would be to self-host these packages, basically. Whatever it might be, however it might be, it is a relatively hard sell, but the benefits really are there. So especially in combination with the, supply chain, if we pull stuff from the outside, we at least have some sort of step in between where we have at least a minor level of control. So, moving on.
There was a question?
Yes.
You said that you want to give a lot of flexibility to developers, but in the end, to put these things in production, is there kind of a way to kind of even blacklist projects, which are not malicious, but they are if you use them, you definitely have issues.
I do believe some package managers have that capability. There is one thing. I'm going to refer to what the previous presenters mentioned, because I personally love OPA. You can use OPA to do these things. You can really use. You can write Rego rules they don't care, because OPA doesn't care what it checks. As long as you just give it a JSON file, it can check that JSON file, whatever it might be, and it's just literally, its goal is to spit out true or false based on the rules backend databases. So you can really, before anything touches, before you do npm build or Python or start build a Python application, build Go, you can just pump the bill of materials to a tool like OPA. If configured properly, it does require some configuration. That's extra work, of course, but it will enable you then to immediately stop the build, because this is a non-blacklisted package, and the data source for that blacklisting, OPA also doesn't care where it comes from, be it the text file, be it the database you go, be it what you pull from the internet. There's really multiple ways of doing that. It's a Swiss Army knife, but you have to learn how to use it. The learning curve is pretty steep initially, but the benefits are immense, because I'll get to OPA in a second as well.
Why would you block something if it's not malicious?
Some projects are dangling projects, which means that they are a ticking bomb. Means that
end of life.
What?
End of life?
Yeah, end of life. 3 years, 4 years, nobody touched it.
That's also possible if you create something that does this check. Yeah, go ahead. Maybe there's one more question.
As a developer, I hate that shit.
The what?
I hate that mindset.
Yeah.
I really hate that mindset, because what you're simply saying is you're not going to communicate to the developers what you really want.
No, because
that's a fun event. That's more fundamentally. Before you should try to kill the tools, you should communicate.
No, this is about setting up guardrails.
Yeah, exactly.
So to protect you guys as well, because
no. The point is, before you try to protect us, communicate. That's
hopefully a given. Everybody, I totally understand. This is not me speaking out. This is basically in that context. I absolutely agree, because you might need certain things, and as I said, for some reasons, some things need to run as it is. We had to reuse the old libraries, right? So for some reasons, we might have to do it.
Yeah, I also like to add, for developers especially, something like to automate lifecycle management, like a renovate pod.
Yeah.
And it automatically creates all the MRs with the update. Yeah. So as a developer, you don't care. Yeah. Someone just approves it and you're done with it.
Because for instance, those checks can be literally implemented, for instance, in your machine as a warning, right? You're using a package that the business decided is dangerous. Expect issues down the line, basically. So then you kind of make a conscious decision also. Okay, I do want to proceed with this. I will justify it later down the line in the merge request or whatever, right? So it's depends on where you put it, and as I mentioned, most of those things can be done simply in a informative manner. I'm not talking here about immediately cutting off a build, immediately stopping everything. All of these things should be looked at in the initial stages as purely detection and information.
Yeah, but even that, the main thing people should be doing is communicate.
No, absolutely. Before all of these things, this is basically that's the goal. That's the hope. So, improper assets management is number 8. I'm going to keep moving for the sake of time. So, asset inventory. I come from a more of an infrastructure background, so I do focus more on that. So, all the big 3 cloud providers have some sort of asset management. It can at least show you, your VMs running, containers that you're running, how your network interfaces look, things like that. Most likely for application, for application stuff, things like CSPM comes in one form or another. There's multiple vendors, including here as well. Plug. So basically, there's open API format scanners, which you feed basically a YAML file that with your state of your API or the layout of your API, and then it can scan and it can detect deviations as well. And generally speaking, observability on the Kubernetes layer, and I'm going to plug in observability slightly later down the line. You can also use admission controllers in Kubernetes to make sure that the deployments adhere to certain requirements. Okay, let's keep moving. Inadequate compute resources, quota limits. This kind of nicely ties into what the previous presenters said as the financial DDoS. So basically, in most cases, things scale. Things are set to scale because things need to keep running. In this case, I used actually request limits and quotas. So these 3 different controls can be used in Kubernetes to make sure you limit the amount of resources consumed and provided to the application. This has to be tested, adjusted, tweaked almost constantly because your applications change. You need to have same thresholds so you also don't kill yourself. Again, Open Policy Agent Gatekeeper is actually a part of Kubernetes right now, which enables you to really write policies to make sure that the deployment has request limits or quotas in the namespace or on the pod level, for instance. So you can make these checks happen relatively easily by, I think all cloud providers right now have just enabled tickbox, and the Gatekeeper service gets enabled on the master plane, and so we can do that. And ineffective logging and monitoring. I'm going to quickly go down the line. So general observability. So this is, plug there again. I'm so more of a open source thing. Falco, the Tetragon is brand new, and actually this is the technology that's being used. I'm not sure how many of you are familiar with eBPF. It's an technology that has been in the Linux kernel from 2010, but only in the, I would say, year or 2 it's really starting to get traction. This really enables you to do, I don't want to say agentless, because the agents reside, but they reside on the host, not inside the containers. And then they monitor really calls that the kernel does, that the container does through the shared kernel space, basically. So, and it effectively can monitor any system call you want and take actions on any system. File opens, a WebSocket opens. So there's both products. Very, I would definitely recommend having a look at that and see if, because I firmly believe they would bring really a lot of value and give you a very good overview of what's actually happening in your Kubernetes cluster.
I think, again, most of it also demands that you have proper function testing and load testing automated already.
Yes. In this case, these both tools will simply generate data for you. And what you do with the data, how do you treat the data, is something that you need to decide how do you go about it, because it's just data points for certain events within the system. But thanks to this, we're really going back to almost like a old way of doing things with audit D. If you have worked with audit D, you really get visibility, proper visibility and observability of events within your Kubernetes cluster. Because without that, I think even the previous speakers mentioned, we don't know what's happening there. We don't really what is the container doing actually. And this is the way to actually see what the container is doing. So this is where my all 55 minutes, but I opted for this. So we cannot solve our problems with the same thinking we used when we create them. So on that note, think outside the box, because we have old problems that we still run into and we still haven't solved, as you saw. Please contribute to the top 10 if you have any ideas, thoughts. If you want to have a chat, absolutely feel free to contact me. But I think we are like spot on.
Exactly. Thank you.